Good morning, wherever you are. Welcome to PNG and welcome to a brief of the Caribou. The Caribou itself holds a very special place in my heart. I have spent a lot of time flying a number of different aircraft, but nothing with quite as much character or fond memories as the time spent with the Caribou. I'll run through a quick overview. It is the DHC-4, also referred to as a CCO-8 or a C7 or a CV2. There's a lot of different names for it, but from the manufacturer, the DHC-4. There was a DHC-5 that followed on from this. The DHC-5, notably different in that it had a T-tail design on the rear, and that gull-wing design that the Caribou is so famous for was dropped on the DHC-5 for a straight-wing design. So that raises the obvious question: why did they have the gull-wing design on the DHC-4? Simple. The aircraft was designed for very rugged landings, and if they had a straight wing design on this aircraft, then the main landing gear struts would be too long to be as strong as they wanted them to be. When they went to the DHC-5, they put the turboprop engines onto the DHC-5s, and they extended the engine nacelles lower down so that they could still hinge the main landing gear in the same way from a lower position and keep it strong. Uh, Beyond the DHC-5, it went to the now famous Twin Otter, still currently used around the world. The difference between this and the Twin Otter, this aircraft has a max takeoff weight of around 28,500 pounds, normal operation, non-ferry. She'll go up to 34,000 pounds in ferry. But that 28,500 pounds compares to the 12,500 pounds, so a little bit less than half that the Twin Otter is capable of. So this is a larger aircraft, but it is literally the granddad of the Twin Otter. And for those that are familiar with the Twin Otter, you will notice a number of features on this aircraft that carry directly across to the Twin Otter design. I'm lucky at the moment. I've spent a lot of time flying the Twin Otter as well. I'll point out some of those features as we move along. But anytime we're looking at an aircraft and trying to review an aircraft with capabilities, uh, more capabilities of a STOL aircraft like the Caribou, there's really three things that I'm thinking about. There's the landing gear, the engines, and the lifting surfaces. Is the landing gear going to be robust enough for the type of operation we want to perform? Is the engine, or are the engines going to give us the kind of reliability to get us in and out of places that are remote? And will the lifting surfaces be able to get us in on the right angle and the right speeds to be able to use those shorter strips, particularly in higher density altitudes? So have a look at the landing gear first. Let's have a look at that nose landing gear. It is, obviously the landing gear is retractable, but in being retractable, it still needs to be robust. The most notable thing here initially is the fact that it has two wheels. Not incredibly uncommon for an aircraft to have twin wheels on the nose gear, but the Caribou ends up running twin wheels for a couple of reasons. One of those is that it's load distribution, so it does reduce the amount of load that is on loose surfaces, so you're less likely to sink into bog and sand, so you distribute the load. But the other reason too is to make sure that you have that steering control when you're taking off from slippery surfaces, and keeping in mind also that the actual methodology you go through for the takeoff with a crew is that the nose wheel steering wheel's on the left hand side of the pilot in the left hand seat. When they're taking off, the pilot's going to be operating that nose wheel steering with a hand up on the throttles, and the right seat pilot will end up guarding the controls, inputting crosswind controls if they're required with aileron into wind, and also applying a little bit of forward pressure just to make sure that that nose wheel maintains good contact with the ground, and therefore the left hand pilot can get good steering control from that nose wheel steering. Another thing that's notable here is that anyone who's looked at Mike Paddy's designs and some of the thought that goes into short field aircraft or aircraft that are going to operate off backcountry strips and so on, keeping all of your brake lines and your frangible part, well, not frangible parts, hopefully not frangible, but all of the parts that can be broken, and the back end of your gear, and that's exactly what we have here. So running your lines down through the back of the main strut, we end up with a weight on wheel switch. So that electrical line that's running down the back of the strut at the moment is a weight on wheels switch. Once you're airborne, it will automatically disable the nose wheel steering, so you don't have to turn the switch off. It's just forward of the nose wheel steering wheel. On the right-hand side of the strut, you'll just see the bottom end of the hydraulic strut that operates the nose wheel steering. It operates on a lever that rotates around a pin on the back of the strut. As the hydraulic strut moves up and down, it's going to end up rotating the scissor link left and right, and that is how your nose wheel steering works. So very, very simple, but extremely robust as well. The Twin Otter actually has that scissor link on the nose gear. There's a reason for that as well, because they use it for steering, so they disconnect the scissor link and pull it forwards, but it's non-retractable. The other thing is this aircraft ends up putting that nose gear right out at the front of the fuselage, which is really handy when you're maneuvering. But the Twin Otter has it further back. Now, the reason for that is the Twin Otter fuselage used to be the Otter, and you need to put the nose wheel steering at a fairly robust portion of the fuselage. What they did in the Twin Otter, when they took the radial engine off the front of the Otter to turn it into the Twin Otter, they ended up mounting the nose gear on what they call Station 60, because that's the strongest part, which means it's further back from the nose, and they put the fiberglass nose section in there to give it the aerodynamics that it needed with the radial engine missing. So main gear we'll have a look at next, and we'll just try and avoid the prop arc here. The main landing gear, the notable number or feature for the main landing gear is that it is capable of taking an 8G landing in the aircraft in general before it needs an inspection. That's a phenomenal impact load for landing gear on any aircraft that I'm aware of. I haven't seen that on anything else. Do have to be wary, of course, as well, that usually the flight engineer is standing up in the back and he's only good for a couple of G. If you hit even 3 or 4G, then we have had flight engineers injured in the past from heavy landings. So the gear itself, really, really simple, clever, and robust. We've got the twin wheels here again, obviously braked. We try not to lock those wheels up when we're doing tight turns. They will turn approximately the entire width of the main truck design that you see here in a small circle, sort of one width to the right. But if you ever try to pivot it on the spot with the brakes, that will actually turn a tighter turn than you wish. And if you do that, you're going to end up trying to pull that nose gear around in a tighter circle than it's really designed for. So that can actually put an increased load on that nose landing gear strut as well. With the gear, we've got twin wheels again, and more importantly, they are side-by-side twin wheels. Why is that significant? When you go into a strip, if you have tandem wheels, so a wheel one in front of the other, like the C27J has, like C130s and so on, those tandem gear, as you turn, they scrub the surface. If you go into the strip once, that's not a problem. If you go into the strip multiple times or with multiple aircraft, every time you turn, you're ripping the strip up. And in some cases, it doesn't take too long before that strip is now unusable. Same thing if you go into sand out in the desert. If you're making multiple turns or even multiple impacts onto that sand, you tend to pulverize the sand, and it gets softer with the passage. So having wheels side by side is a huge advantage. These tires run 35 psi each. It's 38 psi in the front, so much lower than what you'd usually see in an undercarriage for an aircraft. Couple of points. You're probably wondering what that T-tab is, the setup in the middle of the landing gear. That is a simple mechanism that makes contact with the door mechanism up here. These doors have a couple of springs, and it's an over-center spring, kind of like a door of an old Western bar, if you like, that'll spring to a point where it holds itself open, and it'll spring to a point where it holds itself closed. And the wheels, as the contact points right in the middle of the screen at the moment, and the spring is just on the outside. As the landing gear retracts, those tabs make contact and they pull the doors up with them. So no motors opening and closing doors or anything. It's really, really simple. We have a look at the construction of the gear here. Is designed to fold up forwards. That seems a little bit unusual, but it works really, really well for a couple of reasons. First of all, if you had a hydraulics problem and you release the gear, it will come down and be helped largely by the airflow for it to release in the first place. The nose landing gear ends up having an air charge bottle, so most of the nose landing gear extension will be helped by the air charge, and then you can use an emergency hydraulic pump system with a handle to port the hydraulic system into the main gear, and with a selection into the nose gear as well, just to get the gear down. Once the gear is down, you can see a bracket here angled forwards from the main gear that comes down and joins the hinge point on that front bracket. That's an over-center mechanism, so when the gear is down, it's actually held down mechanically as well. That means that it's almost impossible, basically, for the gear to fold up on you. It's extremely strong. The actuating strut, as in the hydraulic ram, sits right up at the top. And another thing that's interesting with that is that as the ram retracts upwards and to the rear, it does a couple of things. It moves those brackets to the rear, and that folds the knee and allows the gear to come up. When the gear comes down, obviously the ram itself is forcing those brackets forwards to lock the gear down. But also the way that it works and the way it's articulated, as the gear approaches the top end of the travel, it actually retracts the main landing gear, makes the main landing gear shorter by pulling everything through the middle of the main landing gear strut and shortening the length of the landing gear system. Keep in mind that when we are flying in the air and the gear is down, that oleo extends, and again the scissor link is going to be extended, so the gear will be significantly lower. So you've got your air spring internally with an oil shock system, standard oleo for most aircraft designs. Once again, looking in here, we've got the scissor link on the back, and now all of your brake lines are routed to the back as well. That's just to make sure that they don't get damaged by stones, rocks, or anything you're likely to encounter when you're running off airways landings. So that's it for the landing gear. Quick chat about the fuselage. It is very robust. I used to fly aircraft tail number 208 over in Western Australia with Black Duck Airlines, and that aircraft had an experimental paint job on it. But when I did some research on that particular aircraft, 208 was in Vietnam. Of the aircraft that came to Australia, at least only the first 3 came direct to Australia. The remainder went from the factory to Vietnam and joined crews there. The 208 though, on one specific incident, they were landing on a strip. They had pulled up and they were resupplying a special forces unit that was under fire. Whilst they were resupplying that unit, they ended up getting a mortar round came off right next to the aircraft that injured the left seat pilot. They did continue and unloaded all the ammunition for the special forces guys, only noting then that the round had also blown out all of the main tires for the aircraft. So 4 flat tires on the mains. That aircraft took off with flat tires, left the landing gear down, and landed back Vung Tau with flat tires, with no damage to the airframe, no damage to the undercarriage. It was just jacked. The wheels with new tires were placed on the aircraft, and it was fully serviceable and ready to go again, which is a fair measure of just how robust these aircraft are. But in flying 208, it still has on it a number of patches from bullet holes and so on from Vietnam era. Which is humbling when you're walking around the aircraft. You realize that it's got quite a history to it. Probably the next thing we need to talk about would be the engines. So the engines themselves are the Pratt & Whitney R2000s, and the R2000s are later than the 1830s and the father to the Wasp 2800. So why does it get the name R2000? It's because of the displacement. So like a lot of the American engines, they're all based in cubic inches. So most people will be familiar with your Chev 350s, 454s, your Ford 351s, and so on. This aircraft is 1992.5 cubic inches, which is absolutely massive, 32 liters, 2 1/3 liters per cylinder, because it's running 14 cylinders total. It's called the Twin Wasp because it's got twin rows of 7 radials. As I said, it's the grandfather of the Wasp 2800. The 2800 had 2 rows of 9 cylinders, and the 2800 by the end of the war had actually reached the point of achieving 1 horsepower per inch of displacement, and it was running 2,804 inches of displacement at that time. The engine is incredibly reliable. It is brilliant. There's even one chap flying a P-47, so same design. 2800 went into the Thunderbolts, went into the Hellcats, went into the Corsairs, and so on. And it was all based off the R2000 engine in the development here. I'll just show you a cutaway of the engine in here, and we'll get a look at the front end with a reduction gearbox. The reduction gearbox actually works the other way. If you look at Pratt & Whitney PT6 engines, turbine engines, you end up with a 15-to-1 reduction gearbox at the front end. This actually has a half-to-1, so the propeller spins at twice the RPM of what the engine does. There are 2 rows of 7 cylinders, as I said. At the back end of the engine, you end up with the supercharger unit. The supercharger unit's taking air from over the top of the engine, bringing it down through the Stromberg carb. That Stromberg carb is about 5 inches by 10 inches in the throat, so it's massive. You can fit 2 fists into it. But from there into the supercharger, and then the airflow goes out around the outside of the engine with the induction tubes, goes into the cylinders, and the exhaust back out into the augmenters. The augmenters are over the top of the wing here. Now, those augmenters aren't sort of welded extensions of the exhaust. The exhaust ports end inside that tube, but there is air coming through the front of the engine here with the intake, not just for the carby, but some of that air goes back through, carries through the augmented tubes, and that actually helps evacuate some of the exhaust gases there and keep it a bit cooler as well. I had an issue with one of these aircraft engines once before. Didn't turn into an issue, but we've been doing parachute work all day in Western Australia with the regiment. 26, 27 runs during the day. We lined up for the last takeoff, and it just felt a little bit strange in the right engine. I couldn't put a finger on it. It just felt different to what it normally felt like. And I spoke with the engineer at the time. He came up, had a look at the engine instruments too, and there was nothing indicating with the engine at all. So we took off, but in taking off as well, I'm still suspicious of the right engine, and the Caribou is not capable of getting off the ground if you have an engine failure prior to rotate. So that brief was an interesting emergency takeoff brief, because you shouldn't do it. When you're conducting a brief, you shouldn't preempt the fact that a particular engine could fail, because that'll set you up for the other engine to fail, and you'll be more likely to pull the wrong levers. However, we got the aircraft back to Perth, no issues, back to RAF Base Pearce, and upon arriving back and shutting the aircraft down, the maintenance guys had a look. They dropped the oil. You can drop the cowls off the bottom of the engine nacelle here, so that whole bottom panel comes off like a bottom half of a kayak, and then the panels on the side open up like the petals on a flower. When they jumped in there and actually tried to drain some oil out to have a look, there was no oil coming out. Now, these engines contain 20 gallons roughly of oil. There's 20 gallons with another 10-gallon expansion room. So if you've got 20 gallons of oil sitting inside and you can't get any of it out by pulling the drain plug, you know you've got a problem. They put up a sieve, screwdriver, rattled around on the inside of the engine, and big chunks of metal came out. One of the first notably sized chunks of metal came out had some of the numbers of the supercharger written on it. And what had actually happened is that the big end bearing at the back end of the main crank, for those that aren't familiar, all of the pistons are operating onto a crank, so the forward row of pistons and secondary row of pistons are operating onto a crank that looks like an old pedal car, if you like. And that's supported at the back end by the big end bearing. That big end bearing had failed. It had gone through into the supercharger housing, torn everything apart with such violence that some parts of the supercharger had gone back through and ended up in the sump of the engine itself. But what's most interesting, to me at least, is that there was no indication of it to us. The engine still performed beautifully, and there have been all sorts of amazing stories regards these aircraft failing even one notably failing in Italy in World War II, a 2800 granted, but it lost an oil line, and they flew something like 350 miles. The pilot flew back. He'd lost it in flak. It had ruptured an oil line, and the aircraft absolutely covered in oil, but did make it all the way home. The engine failed on short final just as he was landing, which is not uncommon either, but it was running without oil for that period of time. So as soon as you reduce the power, that's when you're going to end up getting that engine seizure. So the engines themselves, absolutely incredible in terms of how reliable they are. Whilst we're talking about reliability, that's why your Navy aircraft operating off carriers had radial engines for so long when everyone in the Air Force was using Merlins and inline or V12 engines, because they could take the battle damage and still get you home. And that concept continues to this day, where all your Navy fighters have two engines, so that if you lose one, you can still get back to the ship. Uh, Air Force, like the F-16, single engine, they don't have the same concerns. We just have a closer look inside the engine bay here at the moment. Right at the top, the obvious things there are the left and right magnetos. Magnetos are gear driven, and the idea of a magneto is that it develops the spark through the rotation and then distributes the spark, and it's distributing that spark through the ignition manifold circuit here just outside of that bell housing. The right-hand magneto additionally gets a charge when we're operating the vibe switch, we'll talk about later on, but the vibe switch puts DC power into the right-hand magneto during start, because anytime the engine is rotating, including rotating with the starter motor, it is developing spark through these magnetos. They develop the charge and they distribute the charge, but the right-hand magneto gets a little bit of help during the start, so we get a really nice sharp spark coming out of it. We have a look at some of the lifting surfaces here now, and you'll see the complex bits around the back. I've forgotten exactly how many parts, but it was something like 70 or 80 moving parts in the flaps and the flaperons and the back end of this aircraft. So we have a vortex generator here on the leading edge. Obviously you have the landing light, the wing inspection lights. The wing inspection light carries over to the Twin Otter as well for the location. I suppose that's not that unusual. Wing fence here is to stop the span-wise flow of air. So as you're developing lift, you get lower pressure forming on the top, and the air will tend to migrate towards the wingtips. That prevents it, and therefore reinvigorates the air that's flowing down over your flaps on the inner portion of the wing, same as the vortex generator on the front edge of the wing. It's interesting out here, you've got a bit of a sawtooth leading edge, or a bit of a stagger. Try and get in and look at that. So you may be familiar with a sawtooth leading edge that they have famously on the F4 Phantom, designed to fix a number of the problems that the F4 Phantom had. I think they had the philosophy that people have talked about in the past, whereby if it won't fly, then just put big engines on it and it can do what it needs to do. This droop leading edge means that the outer wing surfaces end up having a reduced angle of attack, so it's kind of like having a fixed slat as a moving leading edge, but it's locked into place. There is a secondary benefit as well, in that this deformation between the two leading edges creates another vortice. That vortice ends up re-engaging or reinvigorating the air that flows down over the aileron sections, the inboard and outboard aileron sections. So that's going to help the controllability of the inboard aileron section, at least as you come in for landing. Now, the aileron travel, it's not uncommon in aircraft for the aileron travel upwards to be a higher scale, a higher magnitude than the downwards travel. But the actual travel of the ailerons in this aircraft does vary with the amount of flap you set. So as you set flap, this aircraft has flaperon, so the entire aileron mechanism out here droops down with the flaps as well. And then the aileron controllability, or how far the ailerons can displace, also changes with that gearing. Another thing that's interesting is that as you put the flap down, you're going to get a significant trim change. There's a fairly significant pitch up, and that pitch up is something you have to counter in the controls to maintain the altitude so you don't balloon with the airframe. In countering that, it's 3 full half turns forwards on the trim wheel, which is quite significant. And that is even with the designed adjustment whereby that entire horizontal stab moves with a gear drive interlink with the flaps as well. So as you deploy the flaps and you get that pitch up movement, the horizontal stab moves at the same time to reduce that movement. So if that horizontal stab wasn't doing its job, you'd have an even bigger problem on your hands as you were trying to deploy the flap. That said, the aircraft flies extremely smoothly. It's very light on the controls. A lot of people have commented about the fact that it doesn't have an autopilot. It really doesn't need one. When you're in cruise, running along about 120 knots indicated, it takes no more effort physically or mentally than cruising along the highway in your car, fingertip control. It's very, very responsive, and you do learn how to trim the aircraft out, because in trimming the aircraft, uh, it teaches you a lot about trim control and effective power and energy maintenance as well. All right, have a look at the flap. I haven't deployed the flap here at the moment, but you'd be familiar with the Caribou. When we put the flap down, the maximum flap setting at least is 40 flap. But when you do put the flap down, you'll see that it looks like the flap is set at a lot more than 40 flap. It looks like it's around 80 or 90 flap on the back end here. So that 40 doesn't refer to the amount that the flap displaces. What it does refer to is the change in the chord line from the leading edge to the trailing edge of the flap. So 40 is the angle change from the current chord line to where the chord line sets, leading edge to trailing edge, once the flap is actually deployed. Power doors on the side are removable. If we're going to use them, then they come off completely. They're removed from the aircraft. Don't do that too often, but it's not like your fancy C-130 with hydraulic doors or anything. The ramp itself sits at 15. We can often set that at level as well, especially if people want to ramp ride. Ramp riding is, set the flap at level, give people a harness so they don't fall out the back, open up the cargo door, and they can sit there and dangle their legs over the edge, which is heaps of fun. It's awesome. With the tail section of the aircraft, we've already talked about the moving horizontal stab. A couple of other things that we'll have a look at, which are fascinating, I think. A lot of your design on your horizontal stab, you have your trim tab sprung, but you've also got geared tabs in there, sprung tabs that end up shifting in such a way that the early loads that you put on the flight control column will actually move the gear tab like power steering to help the elevator move in the correct direction, and then you'll be locked into directly changing the elevator on top of that. Right hand side tends to be where all of your uh, trim controls will sit for balancing things out. The rudder, lower and upper sections that you can see here on the rudder as well, again, bang on carried across to the twin otter. So the lower is a geared tab. As that rudder displaces to the right hand side, the tab will displace to the left. So again, the lower tab gives you almost like power steering, I suppose, for your rudder. Very effective rudder. And your rudder sits, your rudder trim sits up the top. One curious thing that has caught people out in the past is that the Caribou has such a huge rudder, and it sits a very, very long way away from the center line of the aircraft for roll on the roll axis. How that affects you on short final, if you're doing STOL, for example, it is so far away that it ends up acting a little bit more like an aileron than it does like a rudder. It's got that coupling effect. So if you drop a wing normally in an aircraft during STOL and you want to recover, you'll tend to kick in a bootloader of rudder gently as well to help pick up that wing. If you do that in the Caribou, it will exaggerate the problem. You'll actually rapidly drop the wing that's already low, and that did result in a crash in the early days in Nowra in Australia when they're performing a demonstration on a strip in Nowra. That strip, and I can't remember the number of the runway there, but it was the runway. It's not used that often. It heads out towards the west, and it's got quite a steep undershoot on it, so it's quite common to get nasty downdrafts there on short final. Well, that's exactly what happened. When they got that downdraft, it dropped a wing, they went to pick it up. They used a lot of rudder as you would do normally in other aircraft, and the rudder dropped the wing and it landed very heavily. Fortunately, no one was injured. There's a few embarrassed people walking around, but no one was seriously injured out of that incident. Let's have a look at the inside of the aircraft then. So we've talked about the undercarriage, we've talked about the engines, we've talked a little bit about the lifting surfaces. So we'll have a look on the inside. One of the things of note, the ramp here for a start, it is on that 15 limit at the moment. That's to help prevent it hitting anything on the ground if you're taxiing with the ramp open. This is quite a step up. It's where it would normally be, this sort of level and height. But there's more than a few people have caught themselves out trying to jump up onto the back of the Caribou. There's a bit of a handhold here on each side up the side that you can usually reach up to and give yourself a hand up as well. And it does have normally your non-slip all over the back end here, so you don't slip, but plenty of people have slipped and skinned their shins and so on, so that's not fun. So something to be wary of. In the back of the aircraft, we'll get up to the sort of height that you expect to be at. I'm 5'10", and my head, I could just avoid the static cable that usually runs down through the middle or the center line at the top of the roof here. That static cable is for power operations for static line. If you're not familiar, again, the guys will stand up in here to do their power. They'll hook onto the static line, and then we have a winch rigged up at the front of the aircraft as well so that we can pull the bags in because there's quite a load. As the person jumps out the back end of the aircraft here, the bag pulls off their chute and remains attached to the static line on what looks like a bit of a tie-down strap. You'll have a collection of bags there once you've dropped the people out the back, and you use the winch at the front of that static line to help bring all of the bags back in. What does happen though is that the cargo door here ends up getting smacked up pretty badly. A lot of dents and scratches and so on just from the bags thrashing into it. So this is probably one of the best conditioned cargo doors I've ever seen. But when we go to the air shows and so on, people would ask us what that damage was, and quite often we'd tell them that the Caribou was so slow that if we did suffer a bird strike, we'd get hit from behind, which is probably not too far from the truth. Okay, up the top, this is where we store the ramps. Bit of a trick thing to get them out. You just put the cargo door down, walk up the back, and they're not too heavy, but they're resin. They're quite strong. We would put the ramps down, particularly if we're picking up the army guys out in the bush, if they've been out there for a while. It's a bit of a hike to get up there onto that rear step when you're carrying a pack and a weapon and everything else. So a lot better just to put one or two ramps down and help the guys get in and out of the aircraft more comfortably. But the ramps themselves are strong enough as well that we would load up a little Suzuki Jeep in the back here as a deployment Jeep in Western Australia at least. And we would fly, land at an airfield that we'd already surveyed, then we could use the Jeep to go to adjacent areas and survey those areas for landing, for training or for exercises or otherwise in the future. So another pair of ramps rather here, strapped down in the middle of the floor. Good idea to strap them down. You get conditions where it's warmer and you might want to have that cargo door open. But if you get any kind of negative G, things can lift and float out of the back of the aircraft. So I do like the way that they've set up the back of the aircraft here. It's very unusual, but it is a bit of a display to show all the different things that can be done. What you would normally have is either the seats up or seats down, as you see at the back end of the aircraft here at the moment. As you move further along the right hand side, the green box that you have there is a metal box, and that is usually the spares kit or the flyaway kit you call it. So any of the things that you may find essential out in the field, the things that can break, pumps, magnetos especially, you'll have those inside the box as your spares, and maybe the difference between waiting for a week or so out in the bush or getting going in half a day. Flight engineers are extraordinary. Their level of knowledge wasn't unusual for us to have problems, and then at best sit up there and help them on the wing and pass tools and muck in as a crew to try and help get the aircraft repaired again. And as much as that sounds like a bit of a pain in the backside, it really wasn't. Some of the best times we had were doing that. Granted, sometimes the conditions wouldn't be that much fun, but it opened up my understanding of piston engines, especially, and to this day I still enjoy working on Harleys because it's a very similar engine. And yeah, that's fun. Okay, on the left, and I thought on the right as well, but similar to the Twin Otter, you've got emergency exit here for the crew, which is the larger window. On the right, we've got the litter system. The aircraft can be set up for medevac, and that litter system is specifically for the medevac. It's not usually set up as just somewhere for someone to have a sleep. You're more than happy to lie down in the seats here. They're surprisingly comfortable, more than you'd think. Uh, Business end up the front, awesome. On the wall just before we get to the galley area, the spew bags, which will often end up getting used as notepads as well, with different messages written on them and passed up the front. In here on the top, we've got a flask, so you've got some hot water available already. The Army guys, when you pick them up, would certainly appreciate having a cup of coffee with your standard Air Force Nescafe 3-in-1 or similar. Documentation is sitting here. We also have documentation in the overhead lockers left and right. So we didn't have electronic flight books. I know everyone's keen on those now, but we had the actual hard copies of the manuals. Storage area on the left on the top cupboard there. To the right of that, we've got the oven, which is awesome. I know later on they removed it because they said they didn't have paperwork for it, but that oven would run from memory off a 48 volt DC. But you could stick in your sandwiches and so on at the start of the day, and if we were doing several hours of coastal patrol, for example, at the top end of Western Australia, then you fly for 2-3 hours, and then you'd end up having a hot morning tea with a toasted sandwich while you're flying a couple hundred feet down the beach. To the right of that, there's the kettle, basically, where that tap is. You can end up running a a a push pull. What do you call it? A push pull tap thing that you'd end up running off the side of an urn to give yourself a cuppa. And below that, an ice box. So inside the ice box, you have some cold drinks. You have your ubiquitous fruit poppers and the Air Force fruit cake, which was always brilliant. Moving into the cockpit, then we'll get up to a standard height again. I can't do anything about the characters that are sitting up there at the moment, but that's all right. We'll deal with that. As we move forwards, you have this intermediate area through the cargo door, and left and right, we have what we call LRUs, or line replaceable units, which is brilliant because if you did have a problem, then there was very, very easy access. You used to have the old mechanical inverters sitting down the bottom here as well, which make a hell of a noise with wearing away. And they went to solid state later on. This is a solid state system, I believe, that's been installed into this machine. Other things of note, you've got your portable oxy sitting in the packages down there. You've got an access ladder that goes up the left-hand side here, goes through the top hatch. So those who have seen the aircraft at the air shows and so on, you will have seen the engineer sticking his head out the top hatch, giving a bit of a wave. There is a very practical reason for that as well. When you are up through that top hatch, you can see around the aircraft. You can certainly see a lot more than the pilot and co-pilot can see. So he gives some directions as maneuvering in tighter areas and wingtip clearances and things like that. Of course, if you're ever unsure, you get people out and walking, and the flight engineer would have a very, very long lead. And by long, I mean like 20-30 meters, so he could walk around all around the back end of the aircraft and direct us backwards when we're using the 3-point parking and so on. Just here in the right hand side of the top shelf next to the 2 first aid kits is a tie down strap, and it's really cool to see that because that strap is exactly where you grab it from, go out through the hatch on the roof, move out onto the surface of the wing, which we'll have a look at shortly, cast the strap over the side to hook up your avgas hose as you've nosed into the pump to pull the nozzle up onto the wing and do the refuel. So a 2-person job there for sure. But it's so cool to see those sorts of features that are modeled in here. Your hydraulic fluid that can be topped up in flight. We will have a much closer look at some of the cockpit indications and systems during the flight. So we'll talk about some of the things that are in there. But just at the moment, let's have a look at the radio boat in the middle. There's a couple of cup holders on the back end of the radio boat. You have the large trim wheel here sitting on the right-hand side. Very similar position again to what you have in the Twin Otter. The Twin Otter's added your aileron and rudder trim here as well. We have aileron trim. It's on the left-hand side on a hat switch on the left-hand yoke, sitting just to the left of the red switch there. And someone was asking the other day about rudder trim as well. Your rudder trim is overhead. in the middle of the screen there now, so a large rotary just behind the magnetos. Other things, the flight engineer would come up if you had any problems with the aircraft, and you can see from here, you can enter, lean in between the seats, and you get a really good view of exactly what's going on the engine instrument side of the house. So flight engineers, as I said, extraordinarily experienced guys who've been around the bush for a long time, around the aircraft for a long time, and even when you're sticking out junior crews, you'd stick out the or deploy the senior flight engineers with them as well, because they were kind of the patriarchal figures, if you like, to assist the crew with everything they were doing. The back of the seat here, black and yellow handle, is your hydraulic emergency handle. That emergency handle slots into a panel here on the floor just for the flap. That means the left-hand seat pilot can end up manipulating that handle forwards and back to develop hydraulic pressure. Underneath the black panel here, we end up with the hydraulic access panel, as it says on the box. In there, you end up with the pull lever to push the air pressure down into the nose gear. You also have 3 taps in there, basically the on-off taps for the hydraulic fluid, so you can choose where you want to port the hydraulic fluid to, either to the main part of the system or to the brakes, or to the nose wheel steering to complete that gear extension process. Brakes themselves also have access to an air charge, so the handle that you see sitting up here, up in the top between the glare shields covering the instrument panel. You pull that, it's lock wide as a general rule, but you pull on that. The caution is don't pull it multiple times because it is using an air charge. You'll bleed the air pressure, you'll run out of brakes. But if you have an emergency, you pull that on with one nice smooth pull and bring the aircraft to a halt, so you still have that kind of redundancy. If we did have a gear problem, obviously you can go back, look out through the cabin walls to see what's going on with the main gear, and the nose gear could be a little bit trickier were it not for the fact that you actually have a nose gear inspection window here. So if there's any concerns with the nose gear, then the flight engineer could get down here and have a really good look and just see exactly what's going on, and make a decision with the crew then about what to do next. Given that we do have a couple of characters here at the moment in the front seat, it does raise an interesting point of history as well, in that the only aircraft in the history of the ADF to be hijacked was a Caribou in Timor in 1975, which is a little unusual. All right, as we approach the cockpit, you can see a couple of pads down here just above the yellow and black doors in the base of the foyer here to the cockpit, if you like. Those pads, you could come in here and stand up on those pads and hold onto the back of the seats. Now, if you do that, you get up to about this position, and then you can see a great view. So it's a good place to stand, a very common place for the flight engineer to stand to keep an eye on things. If you're running longer distance on a longer trip, we improvise a bit of a seat, again, non-standard really, but the seat would just go from the ladder across to the shelf here for the units, and then the flight engineer would sit there and observe, or whoever wanted to come up. Wasn't unusual either to get passengers up into the right-hand seat and give them a bit of a go at flying the aircraft. So we say we don't have an autopilot, but we would joke that getting a passenger up there, teaching them straight and level, and that was our autopilot. We just monitor them. They would enjoy it. Certainly they'd enjoy it a heap. Good fun. All right, so we'll just talk one more thing in here before we leave the cockpit area. There is that emergency hatch down on the floor. Now, the handle that's just in the middle of the screen there now is the emergency hatch jettison. It's usually black and yellow as well. This hatch, as you're looking at it, doesn't extend to the outside of the aircraft at the moment. There is a void space under that, and then there's a door on the outside as well. It wasn't completely unusual to end up accessing the cockpit through this door as well. So there's a few ways of getting into the cockpit, down the, obviously conventionally through the back and then through the top hatch. You can climb up the side of the aircraft. I'll show you that as well. But if you're doing famine relief, for example, drought relief, floods, that kind of thing, you'd be loading up the back of the Caribou with hay bales. That would completely fill the back of the aircraft. You're not going to be able to enter the aircraft through the cargo area here in the back. So in cases where the aircraft is fully loaded, you can actually come in underneath the aircraft and access the aircraft through that bottom hatch. So something that's a little bit interesting, I guess. All right, we'll go up the ladder and we'll have a look around on the top of the aircraft. So this is the view that the engineer would have looking around the aircraft to the rear. Like, it's not a perfect view. There are still blind spots, but it's a lot better than you're going to get from the cockpit. So it helps a lot, and you can see the wingtip clearances as well quite clearly. But you come up through the hatch here, the black markings on the top are there to help guide you with where to walk. And obviously you'd want to be a little bit careful as well if you came up here and it was wet in the morning, or if you'd had a very cold night, you come up here and there's ice. That becomes treacherous. These squares and the tabs off to the right hand side here now, as we're looking at them, they are push plate handholds, footholds to climb up the side of the aircraft. If you're ever using those on an aircraft, please just make sure you take your rings off, because I do remember a case where a guy climbed up there and fell, and his ring, or his wedding ring I believe it was, caught on the handle on that sheet metal and degloved his finger, and it means taking all of the flesh off the bone, which is pretty nasty best of times. Okay, so you can walk right up to the back of the aircraft by way of an inspection. The flight engineer does a lot of stuff on this aircraft before we go flying anywhere. There's, from memory, looking at the checklist the other day, there's 59 external points they'll check outside of the aircraft, 24 points they'll check in the cockpit, and 23 separate checks that they will perform in the cargo area of the aircraft as well. So flight engineer is very, very busy with this aircraft. We'll come out and still do a pre-flight, of course, but they have done such a tremendous amount of work before we get here. Top of the engine, familiar from the point of view of doing the refuel and re-oil. Re-oil, you say? Yeah, well, when I finished flying this aircraft, it was acceptable under the maintenance rules for the aircraft to burn 2 gallons of oil an hour. So it's got roughly 20 gallons of oil in it, and 2 gallons of oil, that's per engine per hour, is a phenomenal burn rate for something that's not designed for a total loss oil system like the old engines in the 20s were. You can see the augmented tubes here as well. If you were re-oiling, you'd usually do it with tins. If you were on a deployment, occasionally you might bring an oil dolly. Now, an oil dolly is like a 44-gallon drum in a little trolley, and a wobble pump, so someone will pass the oil hose up to you, and you will stick the oil in, and then they will pump until you've got the sufficient quantity of oil into the system. But in oiling, you've got to be really, really careful as well that you get oil over the wing. Occasional dribble will come out, and I know there's been people that have slipped and gone off the back end of the aircraft here as well. So we'll be topping up oil cans over the back and tidy everything up in the end once the job's done. Okay, that's pretty much everything up on the top. I just saw the pitot probe here as well up on the top of the engine cowling, and you can see, hopefully, if I can get down here, I'm going to do something dodgy, lean over the top. There we are. There's the second pitot probe as well that's offset on the other side of the nacelle. So inboard, outboard, upper, lower. Those pitot probes, they're not for the airspeed indicator, because the airspeed indicator one, just like the Twin Otter, sits there forward off the nose. Static vents below it, exactly the same as the Twin Otter as well. So another feature that carried across. But these two are part of the auto feather system. So if you have the throttles up and the system detects through these pitot probes a 45% loss of thrust, plus or minus 2.5%, then it will activate the auto feather system. So you engage that auto feather system for the takeoff, such that if you did have an engine failure, it will beat you to the punch in terms of feathering that blade angle so that it doesn't windmill. Keep in mind that a windmilling prop, one that's being driven by the wind, has about the same amount of drag as having a solid disc. So if you can imagine a solid disc of plywood sitting out there on the front of that dead engine, whilst you're trying to climb somewhere around here on one engine, that's not really what you want. So the auto feather system operates using thrust. The newer systems, like on the Twin Otter, end up using electronics to detect where your PCLs are at, where your power control levers are at, and what sort of power is being produced by the engine. But you can see the basic concepts came from the granddaddy of the Twin Otter. That pretty much completes what we want to have a look at on the aircraft now. So we'll just drop outside and get the table and chairs packed up and prep for takeoff. For anyone thinking that the table and chairs here set up under the wing of the Caribou seems a bit frivolous, a little bit non-military like, I can assure you it's not. You do whatever you can to make sure that you're comfortable, and certainly we would try and keep equipment on board, especially if you're going out to spend a day doing something like parachute drop operations out in Beverly or something. We spend the day out there in Western Australia, and while the guys are repacking their chutes or taking a break, it was nice to be able to sit there. We even take out a coffee brew machine, end up having fresh brewed coffee sitting out in the bush and enjoying the day. So not frivolous at all, some would say essential. All right, we're going to pack everything up and get cracking. We're going from here, this is Asimba, we'll go up to Yongay. So right now, obviously, we're looking out to the east in the morning. So north up the left-hand side, low ground out to the right, out to the south. We'll be heading up that valley and around to the left up to the backbone of PNG, but before we reach there, we'll go to Yongay. Then we'll go across the backbone up around 11,500 feet down to a strip called Fane, and we'll depart there and head off to Tapini. Tapini is one of the strips that was quite popular for STOL trainers. STOL trainer bringing a couple of aircraft up, at least you have a couple of aircraft for mutual support, and operate around Papua New Guinea so that everyone gets to practice, experience, wave the flag, support the locals, make sure we've got information that is up to speed on all the different strips, because they do change over time as well. Anyway, we'll pack it all up and we'll hit the road. Cheers.